When solving a problem like example 3, it's a good idea to sketch the vertex, the focus, and other features of the parabola as we solve the problem. This makes it easy to see whether the axis of the parabola is horizontal or vertical and the relative positions of its features. Exploration 2 walks us through this process. Now, here's the graph that we're going to use here for exploration number 2. Now, I realize we didn't do exploration number 1, but that's okay. Now, number 1 says, let the focus f of a parabola be 2, -2, and its directrix be y equals 4. Draw the x-axis and y-axis on the graph paper, then sketch and label the focus and directrix of the parabola. X and y-axis are already drawn for us. So if I plot 2, -2, there's my focus. My directrix be y equals 4. Here's a vertical line, y equals 4. Number 1 is done. It says locate, sketch, and label the axis of the parabola. What is the equation of the axis? Well, what we're going to do here is my axis. My axis will go right through my focus and is perpendicular to the directrix. Here is my axis here. It is the equation y equals -2. Locate and plot the vertex of the parabola. My vertex will be halfway between the focus and the directrix. That means my vertex will be right here, which means my vertex will be at 3, -1. What are the focal length and focal width of the parabola? Well, the focal length should be nice and easy to figure out, because that is P, and the distance between the vertex and the focus, that is P right there. That means P will equal 1, which means my focal width will be 4 times P, or 4. Now it says, use focal width to locate, plot, and label the endpoints of a chord of the parabola that parallels the directrix. Well, what we do there, because the focal width is 4, we're going to go up 2, put a dot, down 2 from the focus and put a dot. This chord is parallel to the directrix. Now we need to sketch the parabola. To sketch this parabola, we're going to go from our vertex through the points, right like that. There's our parabola. Now, which direction does it open? This opens left, which means P, 4P is negative. Now, the equation in standard form, well, because it opens left and right, that means it's going to be y squared. So y minus k squared is equal to 4p times x minus h. There's our standard equation. So our k value is -1. So y plus 1 squared is equal to 4 times p. So 4 times 1 is 4, but it opens left, so it's negative x minus 3. There's your equation right there. Not too difficult to create this equation, but again, it is helpful if you do graph it first. Now, sometimes it's best to sketch a parabola by hand as an exploration 2. This helps us see the structure and relationships of the parabola and its features. At other times, we may want or need an accurate active graph. If we wish to graph a parabola using a grapher, we need to solve the equation of the parabola for y, as illustrated in example 4. Now, we're going to solve both of these equations for y. Easy way to do this, in order to get rid of a square, we need to take the square root. Now, we don't need to simplify this when we put this in our calculator, which makes it actually really nice. Now, to further solve this for y, there will be our equation. Now, the way we put this in our calculator is actually pretty simple. We're going to go 4 plus the square root of 8 times x minus 3, and then 4 minus the square root of 8 times x minus 3. So that's what our graph will look like. Actually, I'm going to change the window so we see it a little bit better. So there we have it. There is our parabola that we graphed on our calculator. Now in example B, we're pretty much going to do the same thing. We're going to take the square root of both sides. Then we're going to subtract 3. Now as you can see, because it's y squared, we know it's going to open to the left and to the right. Because it's a positive 12, it's going to open to the right. So when we put our equations in, we'll have a graph here. Let's actually change the y value here a little bit. There's the top half of our parabola. Here is the bottom half of our parabola. By doing it this way, it actually makes it really, really nice and easy to graph and to check your work on your graphs. Now moving on to example 5, we're going to have to write this graph that's in standard form. We're going to have to find the graph of the equation of the parabola, find its vertex, focus, and directrix. Now the way we do that is actually not too bad. Because the y is squared here, we're going to leave that on this side, along with the other term of y, and put the other terms on the other side of the equation. As you can probably guess, we're probably going to have to complete the square here. Half of 2 is 1, 1 squared is 1. We're going to add that to the other side as well. So I have y plus 1 quantity squared when you factor. Those two numbers that multiply to get 1 also add up to 2. It's going to be 1 and 1. That's going to equal 6x minus 12. Now you can go a little bit further here. That equals 6 times x minus 2. That means your vertex will be 2, negative 1, because we're going to take the opposite of the negative 2 and the opposite of 1 there. Our 4p is equal to 6. That means p is equal to 3 over 2. Now going back to our chart from before, because it is y squared, we're going to actually use here h plus p, k is going to be my focus. H plus p, k. So because my focus then will be h plus p, k. This will actually simplify. 2 plus 3 halves is 3 1/2. Or it could be 3 1/2 would be 7 halves, negative 1. There's your focus. Now looking also back to the chart here on the previous page, our directrix is x equals h minus p. X equals h minus p, so if my h value is 2 minus 3 halves, that means my equation will be x equals 1 1/2 for my directrix. Moving on to example 4, because the x squared, or the x is a square term, we'll leave that on one side, move everything else to the other. Again, we're going to complete the square. Half of 2 is 1. 1 squared is 1. So I have x plus 1 quantity squared is equal to y minus 2. Now, because you can't take anything out, really you're taking a 1 out. That means my vertex will be negative 1, 2. My 4p is equal to 1, which means p is equal to 1/4. Now again, going back to your chart, you should see, because it's x squared, your focus is going to be h in k plus p. So negative 1 and 2 and 1/4. 2 and 1/4 is, you could also write that as 9/4. Your directrix will be y equals k minus p. So there's your vertex, focus, and directrix. Really not too bad. I think you guys should not have much trouble on this at all.